Okay, so amplitude, we know we're looking at the A value, in other words, the number that's in front of our sine or cosine, or in this case, our secant or our cosecant. For period change, remember we do 2 pi over B. The B is the number in front of the X. For our phase shift, remember we're plus or minus a value inside the parentheses with the X. And that shifts us left or right. And then our vertical shift is a plus or minus D. And that can be, sometimes I add that to the front, sometimes you see it attached to the end. So just kind of be conscious of that.
What does the C stand for again?
The C is it's our phase shift, and that's usually, it's gonna be a value of pi, it's gonna have a pi attached to it, right? It's gonna be that we're shifting left pi over 4, right pi over 4, or something like that. Yes, Christopher.
Is the horizontal and vertical phase shift the same for cosecant as well?
Yes, it's going to be the same for all of those. So I'm just putting it in one place because we don't need to write all of that down. All right, so let's look at our cosecant graph. Cosecant is the reciprocal of what trig function? Sine, yeah. Okay. So remember what we're going to do in order to graph the cosecant graph is we're going to lightly draw in. I'm not going to label all of these, but you can see here's pi, that's our middle, and 2 pi. So we're going to lightly sketch in what the sine curve would look like because we're going to use that to kind of help us draw in, remember what our cosecant graph looks like. So we're looking at where the y values are equal to 0. Because if we take the reciprocal of 0, we get undefined. So remember what that corresponds to is where the sine graph is crossing the x-axis. So remember we get asymptote at 0 and at pi and at 2 pi. And then remember we look for that high point, that highest maximum value, and we reflect the shape of that curve there. And then our lowest value here, and we reflect the shape of that curve here. So that's what our cosecant graph looks like. That pink there, okay? That's for cosecant. For secant, we know secant is the reciprocal of cosine. I'm going to change this again also up. So if we lightly sketch in a cosine curve, and then we are looking at where this cosine curve, where the y values are 0, in other words, where it's crossing the x-axis. So that's here, that would be pi over 2, and at 3 pi over 2, there's our asymptotes. Remember, this is our minimum value. That's our low point. We're going to draw that point and reflect. And up here, we draw this point and we reflect. And this point and we reflect. And then remember, I told you, if you want to add in this other side of this curve, just to help with the shape of that curve, that you can do that. Okay. So that's a cosecant curve and a secant curve. All right, let's look at, we're going to draw a cotangent here. We're going to actually flip to the next page and actually draw a tangent graph on that next page, just so that we have those to kind of refresh our memory about them, okay? So cotangent, if you recall, cotangent actually has a period of pi, so does tangent. The only other adjustment that you guys saw that we did was an amplitude change with our tangent and our cotangent. So kind of keep that in the back of your mind. So these you kind of just have to get memorized. Your cotangent graph, remember, you're going to go from 0 out to pi. So we have asymptote at 0 and at pi. I'm going to zoom in here. We've got pi over 4 and pi over 2. and 3 pi over 4 and pi. So here's our midpoint. We know our midpoint, we're going to be at 0. Our cotangent graph goes up to the left and then down to the right. So those are the critical points that you're going to have to show me. So pi over 4, 1, and then 3 pi over 4, negative 1. And then that pi over 2 at 0. Okay? So cotangent, remember, goes up to the left and down to the right. And it goes from 0 to pi. Okay? For a full period of pi. All right, let's take a look at tangent. So do me a favor and actually flip to the next page, page 30. And this is just some review and practice that we're probably not going to get to. It might be good for you to do if you feel like you want or need more practice, but we're going to borrow this space. So go ahead and cross that out, and let's put a y equals tangent of x here, just so we can refresh our memory about what this looks like. So once again, the period for tangent is pi. And we're going to go out pi over 4 and pi over 2. So we're going half the distance to the right and then half the distance to the left. And then that's where our asymptotes are. So our midpoint is right at the origin for tangent, and at pi over 4, we're up at 1, that's critical point, and at negative pi over 4, we're at negative 1. So those are our 3 critical points. And then this one goes up to the right and down to the left. Okay. All right, so that's our basic, yes.
Would you give like a period change to the tan?
No, I will not.
Would you give horizontal?
No, I might give you an amplitude change on a tangent or a cotangent, but that would be it. Okay? Okay. I mean, I don't know. I could see maybe giving you a vertical shift also. Going up something, but yeah, I'm going to probably really mostly be focusing like on the main transformations we're going to be looking at on sines and cosines, where we practiced them. Okay?
What does change look like on that?
I'm sorry?
What does amplitude change look like?
Amplitude change, if you've got this in your notes somewhere, if you go back and look, but let me add something here. If we had a 3 out front here,
Yeah.
Luca, remember at pi over 4, instead of just going up 1, we're going up 3. And so then we would go down 3 here. So yeah, remember it kind of stretches it out and makes it less curvy. And that didn't get drawn in there very well, but you can kind of see. Okay, other questions on secant, cosecant, tangent, cotangent? Okay, one other page I want you to move to, just to fill in kind of the last little bit of this. I think we filled in some of it, is on page 42, so near the end. I think we had done some up top. So we already did sine and cosine. So we're not gonna fill in a whole, we're gonna kind of just do rough sketches of this. But I think this is a good reference for some people to kind of go back and look, so I want to have this for you. So we know we have y equals tan. So for our tangent, we know we are going a little bit to the left, a little bit to the right, and then we are going up. Whereas our cotangent, we go all the way out. We go from 0 out to pi. And then remember, we're going up to the left and down to the right. So just a rough sketch for that. The period for both of them is going to be pi. You may see an amplitude change up front, but you're not going to see, I don't know, probably not on those. For cosecant and secant, so cosecant, remember, is the reciprocal of sine. So I need you to kind of visualize what that looks like. But ultimately, that's a rough sketch of what our cosecant graph looks like. Our secant, remember, our asymptotes are in different place. And they go up first, and then down, and then like that. And those are the ones that if you want to add the extra little part to the graph, you can. Okay, so the period, remember, to find the period, I'm going to write this for both, is 2 pi over b. The amplitude is the absolute value of a. Our phase shift is going to be similar to what you just saw over there. I'm going to write it again. X plus or minus c, and then this is a plus or minus d. And that can be in the front or in the back.